Hi guys, it's Miss B. So today we're going to solve some exponential equations algebraically. So just before we start, let's talk about what an exponential equation is. An exponential equation is an equation in which the unknown occurs as part of the index or exponent. For example, so if I do write 5 to the power of x is equal to 25, we can see that the unknown is in the power. It's there, okay? So that would make an exponential equation. So how are we going to solve this? There are different ways. So it could be solved, graphing or using technology or using log. But today we're just going to solve them, algebraically. So how are we going to do that? So we do have two sides of an exponential equations, and we are trying to write both sides as powers with the same base. So what do I mean by that? Both sides with the same base. On the left-hand side, we have 5 to the power of x, and on the right-hand side, we have 25. Now, we want to have the same base. On this side, base is 5 to the power of x, and we have a number 25, and we're thinking, how can you write 25 with the base of 5? It's going to go, 5, and then to the power of 2 is actually 25. And we do have equal sign here, which means that both sides are equal. When you do have the same base, which is 5 in this case and 5 in this case, and you have equal sign, then all we have to say that indices, in order for this equation to be equal, indices have to be equal. So therefore, we can write x has to be equal to 2, and that would be solved an equation. So this one it's pretty simple one. So let's go with another one. So if we do have 2 to the power of x is equal to square root of 2, how are we going to solve this? We can see we had 2's on both sides, but on the right hand side the base is not 2. So what we're going to do is actually convert this into index form. We do know square root of 2 is the same as 2 to the power half. So you have seen that before. Now again, we do have the same base, 2 and 2. Beautiful. Now all we have to do is equate the indices, so which means x is equal to half. And this would solve this equation as well. Now, let's do a few more. Okay, so another one. What about if we do have, for example, 3x plus 1 is equal to 1 over 27. Now, we don't have the same base, but we're looking, okay, we have 3 here, that's nice. We have 27 there, and that actually, it does ring a bell. So we do know that 27 is the same as 3 to the power of 3. Let's just check that one. 3 times 3 is 9, times 3 is 27. Beautiful, that's correct. Now, we're going somewhere. So looking at this expression here, and applying index law, we do know that this fraction can be written as 3 to the power of negative 3. Hurrah! Now we have the same base. Beautiful. We are happy with that. All we have to do now is to equate indices. So, because we have equal sign here, so equal sign there. So therefore, we are going to say that in order for this equation to be correct, x plus 1 is equal to negative 3. And now we have to solve it, so we do need to find what is the value of x, and which means we have to get rid of plus 1. How are we going to do that? We're just going to do inverse of plus, which is take away 1 and take away 1 on both sides. Plus 1 take away 1, it's gone because it's 0. So therefore we are left with x is equal to -3 take away 1, it's -4. So it is equal to -4. Hola. That one is done. Okay, what about another one? So the next one that we're gonna do is 4 to the power of 2x plus 1 and is equal to 8 to the power of 1 take away x. As we said before, so in order to solve it, so we're looking, to have the same base on both sides. So you can see 4 and 8. So it's like, okay, I do know that 4 can be written as 2 to the power of 2. So I'm just replacing 4 here and then copying the index. Equal to 8 can be written as 2 to the power of 3 and then to the power of 1 take away x. Now, we have the same base, and what we do know from index law, that this here power to the power, this power to the power is the same as, let's just go one more step, is the same as 2 to the power of 2x plus 1, so we can multiply that, and is equal to 2 to the power of 3 times 1 take away x. Now looking, yep, we have the same base, beautiful, it's here, so we don't have to worry about the base anymore. And now we're gonna equate indices, just this one. Okay, so therefore, in order for this exponential equation to be correct, this left-hand side has to be equal to right-hand side. And we have to find the value of x. So now expand the number in front of the brackets does multiply every single term inside the brackets. So 2 times 2x is 4x, 2 times 1 is 2, is equal to, 3 times 1 is 3, and 3 times negative x is negative 3x. Now we do have unknown on both sides, so we're gonna put them together. We're gonna collect like terms. So we're gonna get rid of negative 3x on this side by doing the inverse, which is plus 3x, opposite of negative, and plus 3x on this side as well. So what is this gonna give me? 4x plus 3x is 7x, and it's equal to 3, because negative 3x plus 3x is 0. So I'm just going to go on this side here. So 7x is equal to 3. We still haven't solved it for x. So we do have 7 x's and we do need 1x. So what I have realized, I have to go back here so that I didn't copy. I'm just going to put that in another color. I had to copy plus 2 here. Forgot. Yes, silly me. So I'm just going to erase this one here. Now do it again. So yeah, 7x plus 2 is equal to 3. Now we need to get rid of plus 2. So we're going to do that by the inverse, opposite of plus, which is negative and negative. So therefore, 7x is equal to 1. 3 take away 2 is 1. And because we have 7x, we need to divide both sides by 7 to get just 1x. And that is going to give us x is equal 1/7. So I would leave this in a fraction form. So, and we have solved this one.